Welcome learners for the lecture 16 of a differential geometry. Let us go started as the definition where we given as a surface of the points. Okay, the direction of any tangent line to the surface of the point P is called as the direction on the surface of that point will be generated. From the very definitions of the directions of a surface, you know that direction will be given to the form when how to move to the tangent normal in this form. Okay, then after that we say that definitely many direction and the each points of the surface. In the remaining part of this chapter, we will make to the study of the tangential vector to the surface. These are the vector whose normal component are 0. We notice that to the example, that is a vector A is the form of A equals to lambda r1 plus mu r2. The component of tangential vector A at a P lambda mu. So we have to write A as a small a is generated as a value lambda mu into lambda mu. Okay, in a two part, they both of the same direction will be multiplied to the each other. Is the direction on the surface at a point P, means that a lambda r1 plus mu r2 will represent a vector P along a tangent to the surface P. In all our discussions, components means the tangential part of the component vector lambda and mu, that is a tangential vector with the component lambda mu. From the definition we noted that a property in this tangential part to defining to the surface how to cover and direction will be changes to the form of the definition. Okay, this is the property will be given. If a equals to lambda mu is a tangential vector at on the surface, then its magnitude will be given, that is a mod of a to generate it as a part, that is a square root, but it will be generated as the power of this part. Okay, degree will be considering in this form, that is a e lambda square plus 2f lambda mu plus g mu square half will be generated in this form. Then from definition we have a equals to lambda r1 plus mu r2. They generated to the form, that is a mod of a square a into a equals to mod of a square equals to a into a equals to generated to the form, that is a lambda r1 plus mu r2 into lambda r1 plus mu r2. This property will be given in the previous we explaining to the form. Okay, then after that they solve to the example, that is a mu r1 into mu r1, that is a lambda square to r1 square, both of this multiply plus 2 times r1 into r2 lambda mu equals to lambda square r1 square plus 2 r1 into r2 lambda mu plus r2 square mu square. Okay, by mistake this will be considered as a plus sign. Okay, this will be the form is generated as a plus sign because they both of this multiply to each other. After that, you know that e equals to r1 square, f equals to r1 into r2 and g equals to r2 square. Then we get it as a equation same as the above equation. Okay, mod of a square equals to e lambda square plus 2f lambda mu plus g mu square gives to the equation, that is a mod of a equals square root of a e lambda square plus 2f lambda mu plus g mu square will be generated to the form. Okay, this is first definition. After that definition, second to given as the direction of the vector in the tangential form. Okay, let B be the unit vector along the tangential vector A at a P. P points will be considered as a two vector, that is a B is a unit vector and A will be generated to the form. Let the component of B, that is a LM, so that B equals to LR1 plus MR. The component LM of the unit vector B at a P along the direction A are called as a direction coefficient of A. Okay, both of this consideration only explaining to the direction of the vector. Okay, coefficient will be generated. This direction coefficient we written as a LM from the definition of a LM. Minus L minus M gives the direction opposite to the LM because both of these sign will be changes in this form. Since B equals to LR1 plus MR2 equal and generated mod of A equals to 1, we have from the property following definition, EL square plus 2FLM plus GM square equals to 1. Hence the direction coefficient satisfy the above identity and give to the direction coefficient. Okay, both of these definition explaining to the direction coefficient of A and B in the both of this part, and we solve or the concept will be clearing about the tangential part, how to the direction coefficient will be generated. Okay.